Hi, this is Dr. Eddie Morgan over at Clovis East High School. I want to help you get ready for your test. So let's look at the Unit 8 review. Let's get started. Our first problem asks us to name the transformation that is occurring between the two trapezoids, and then asks, is it a rigid transformation? Well, notice the shape here not only moves over here, but actually turns. And if you can see the turn, it's actually turning that direction. Notice it turns down so that the small side is now on the right, and it's turning counterclockwise 90 degrees. Now, is it a rigid transformation? Well, as rigid motion means it retains its same size and shape. And if you were to compare these two shapes, even though they've rotated, they are. So yes, this is a rigid motion because it preserves distance and angle measures. What is rigid motion? Rigid motion is a transformation in the plane that preserves distance and angle measures. In other words, the shape doesn't change size. In rigid motion, the figure may be translated, rotated, and even reflected, but it doesn't change in size. That is rigid motion. And for problems 3 through 8, describe the transformation represented by the coordinate notation. Now, in the first one, you notice one thing that happens here is that x stays the same, but y gets flipped over. So if I have a point here, and here's my x, the x is going to stay the same, but the y is going to flip over. So what you have here is this is actually a reflection across the y-axis. Notice the values of x stay the same, but they flip over the x-axis. On the next one, notice x stays the same, but y goes down 1. So this is a translation down 1. In other words, you see ABC, everything moves down 1. In number 5, y stays the same, but x goes up, goes right 2. Positive for x is going to go right 2. So this is going to be a translation right 2. And it looks kind of like this. Notice AB, every point A moves over 2, each point moves over 2. That's translation right 2. Problem 6, you notice that. One thing you notice is that the x and the y actually change places here. Okay? When that happens, you know that you're dealing with a rotation, either 90 degrees or 270. In this case, we're dealing with a rotation 90 degrees counterclockwise. Take a point like here. Let me take C. C is the point 1, 2, 3, 4, 4, 1, 2, 3. Now, if I use this translation, C prime is going to be minus 3, 4. And notice if I go over here, minus 3, 1, 2, 3, up 4, I end up there. And sure enough, you see how that's rotated over there. And that's a 90-degree rotation. On the next one, they stay the same, but they both x minus y. This is indicative of a transformation 180 degrees. In other words, it completely flips around. So let's look at C again. C, which is 4, 3, if I change it into minus 4, minus 3, I end up with minus 4, minus 3, and there's my C coming all the way around. So that's 180 degrees all the way around. In number 8, you notice we have x minus 2. That means that's going to go left, negative to 2, plus 3 means it's going to go up 3. Okay? So that's a translation left 2 and up 3. And you can see each point goes left 2 and up 3. Number 9 says, name 3 transformations that will map a shape onto itself. This one has a bunch. Because it's a perfect square, you can not only translate and rotate and things, there's a bunch of them. So let me list a couple. First of all, I could rotate it 90 degrees and notice it would stay the same. I could also rotate it 180 degrees and it would just turn all the way around, or even 270, or even 360. The other thing you notice, I could rotate it, I could reflect it across the x-axis, which means this side, this side comes down and this side comes up, and I'm back where I started from. I could also do the same thing across the y-axis. This point would come across to there, and this point would come across to there. I could even reflect it across the XY line. Notice here, this line would go across there, and this one would come across here. So there's just a bunch of reflections that you can do on this one. On the test, you're probably going to have a rectangle, so you won't be able to do all of these because a rectangle is a little bit different shape, not as consistent. But notice I could also reflect across the y equal minus x line. So there are numerous ones there. Problem 10 says that triangle ABC has been rotated 90 degrees clockwise about the origin to present the ordinate. So 90 degrees clockwise means that I'm rotating this way. So notice as I rotate it, B rotates over to R, C rotates over to O, and T rotates over to A. So we keep that in mind, and we'll notice that triangle ABC rotates to triangle TRO. But then as I list angles, angle A becomes, as we said, angle T, right here, angle T and A. And then angle B goes over to R, and C goes over to O. And we can also do the sides. If you look here and just use these letters here, you can repeat the sides. Just make sure every place you change it, you use the same letter. So AB, notice AB becomes TR. So that side becomes TR. BC, right here, BC becomes RO. And finally, CA, which is here and here, becomes OT. So once you've established the angles, the sides can be just done by substituting in the same letters. The triangles at the right are reflections of each other. Name the congruent parts. Well, first of all, notice how they're reflected. They're reflected across the y-axis. So notice that A is reflected over to D, and so A is go to angle D. F, on the other hand, is reflected over to C, and angle B is reflected over to E. Now, as I noted a little bit in the last question, after you identify the angles, you can use the letters to identify the segments. In other words, you notice that A goes to D, and B to E, and C to F. So when I'm looking for DE, I just look down here. DE is going to reflect to AB. If I look down here at BC, right here, BC, that's going to go to EF. And if I look here at FD, FD is going to go to CA. Pretty simple. If you can identify the angles and the sides, are really simple. Problem 17 says if the quadrilateral play, PLAY, is translated with the rule xy goes to x minus 3, y plus 5, what are the coordinates of P? Notice this is a simple translation where x minus 3 means I'm going to go left 3, and y plus 5 means I'm going to go up 5. So here's my point P. So where does that go? All right. So I'm going to go up 5 and left 3. Notice it didn't matter which order, and I arrive here at the point minus 6, 5. But let's do it with the coordinates just to make sure that we're right. And so if we put in here minus 3, 0, minus 3 is minus 6, and 0 plus 5 is 5. So yes, we arrive at the same point. So the answer is P prime is minus 6, 5. Number 18, we're going to take the same quadrilateral and reflect it across the y-axis. What are the coordinates of L prime and y prime? Well, the y-axis is right here. And so remember, when you reflect across, however many units it takes to get to the y-axis, you go across the same on the amount in the other. But so in this case, L, it gets 1 over there, so 1 over there. So there's my new L prime. So this is going to be L prime right here. And that looks like it is 1 minus 5. Let's check it out with the coordinates, though. If I put in 1 minus 5, the opposite of 1 becomes positive 1. And indeed, that is the answer. On the other hand, when I go from y, I'm going back the other direction. I go back 5. So I go 5 past the y-axis to this point here. And this is my new y prime. Okay? Now the coordinates of that, as we can see on the graph and here, notice the 5 becomes minus 5 and my minus 1 stays the same. So the coordinates of y prime is minus 5, minus 1. So on this problem, you can check it out both with the coordinates notation, or you can do it on the graph. When we come to rotations, it says if play is rotated 90 degrees clockwise, that means if I'm sitting here, I'm going to go 90 degrees that way. About the origin, what are the coordinates of A prime and L prime? Well, we can do this graphically. It's just harder for students to do that. You know, for example, if I were rotating P, well, let's check another point here. Let's point A prime. Notice that A prime is, I could draw a little slope here. And notice that is 4, 1, 2, 3, 4, and down 5. And so if I rotated it up this way, the 4 would move up to here, and the 5 would move out to here. And so A would technically move here to A prime. Now, if I check it out with my coordinate notation, which is actually the easiest way to do it, notice 4 and 5 switch, and y becomes negative. So negative 5 becomes positive 5, 4. And you can see that what we've done there is the correct answer, 5, 4, right here. At the same time, if we do the other one, if I did L, we're doing L next, okay, L. L is here, and notice that, let me do it in blue so we don't get confused. L here, and notice if I did my graph here, it goes down 5 and over 1. So when I rotate it, it's going to end up over here. All right, so let's take a look at L. Notice we switch them. The minus 5 becomes negative, and so as you end up here, as you would take here and go over 5 and down 1, if I move my rectangle down like this, you see coming around here, I end up at that point, I actually end up at Y, the original Y, and that becomes my new L prime right there. So again, you can do it with the triangles, take the slope triangles and rotate them. You know, I can take a slope triangle like this, and then I rotate it 90 degrees. And that point becomes that point. Or it's easier just to use this formula here to find your points. Now 20 says, if play is reflected across the axis, what will the slope of P prime Y prime be? Well, here is my x-axis right here. All right. So notice, first of all, when I cross P, P is not going to change. P and P prime are going to stay the same. But Y goes up 1, so it's going to go up 1 again. So it will be right here. And so this will be my new Y prime. Okay. Now, if you look at the slope there, you can see that rise over run, change in Y over change in X. So it goes up 1, and it goes over 1, 2, 3, 4, 5, 6, 7, 8. So it is 1/8. All right. But let's do it now out with the notations. And notice if over the x-axis means that y changes. So minus 3, 0 stays the same because the negative of 0 is 0. So just like we saw, P and P prime are the same. And then y, 5 minus 1 becomes 5 positive 1, as we saw here, y prime. And so if I'm doing the slope this way, I'm going to have my slope is going to be the change in y is going to be minus 1, 1 minus 0 over 5 minus minus 3, which becomes 1/8, just as we thought. Okay. One thing to notice here, interestingly, is that the original slope was down 1 over 8, but when we reflect it across the x-axis, the rise reverses, so our slope becomes the opposite. So when I reflect over the x-axis, my slope just becomes the negative, the opposite. Now, as we move into rotations, as I mentioned to you, it's easier in rotations to use your coordinate notation rather than to try to actually rotate it manually. You can do it with the slope triangles, as I said before. You know, I can find a slope triangle. I can take a slope triangle here, rotate it once, rotate it again, and rotate it again, and come down to my new triangle down here. That's possible, but I usually find it easier just to do the algebra of the math. So the slope rotation of 270, the x and the y changes place, and the x becomes negative. So if we take our first point, A is 4, 5, so they switch, become minus 5, and then the x becomes minus 4. And then likewise y, 5 and 1 switch, so I get minus 1 and 5, but the 5 becomes negative 5. Now we just use our slope formula, okay? The change in y, minus 5 minus minus 4. Don't forget minus minus 4 is plus. And then the change in x, minus 1 minus minus 5. And so we end up with minus 1 over 4, or the slope is negative 1/4. Problem 22 is a relatively simple question problem. It's just asking you, if you translate x minus 7 and y plus 2, where does y prime end up at? Remember, x minus 7 is simply going to mean I go left 7 and up 2. Now, if I want to do that manually, I could take y and say, okay, I'm going to go left 7, 1, 2, 3, 4, 5, 6, 7, and up 2. So this should be my y prime right here. Let's do it, however, with the coordinate notation. So there's my notation, and let's plug in 5 minus 1. So 5 minus 7 becomes negative 2, and negative 1 plus 2 becomes 1, and sure enough, that's exactly what we got there. Problem 23 tells us that we're going to rotate the quadrilateral. Doesn't tell us how much, though, but it gives us the rule, and the rule here is xy goes to minus yx. If you know your rotations, you recognize that's a 90-degree rotation. All right, let's apply the notation and see where it ends up here. And so I'm going to put in the point A right here, which is 4 minus 5. Notice the 4 and the minus 5 switch, but now, again, the y becomes negative, so the opposite of negative 5 is positive 5. And so we get the point 5, 4, which is going to be right here. Now notice you could do it manually, and again, you do that by kind of drawing a triangle here from here to here to here. And notice this is over 4 and down 5. So when I rotate it, it goes up 4 and over 5. And that's exactly where our point was. Problem 24 asks, if the quadrilateral play is rotated 180 degrees about the origin, will it be congruent to play, P-L-A-Y prime? And the answer, of course, is yes, because a rotation is a rigid transformation. If you translate, reflect, or rotate, the figure preserves distance and angle, so it will be congruent. So we know with a rotation, it's going to be congruent. For problems 25 and 26, they ask us to describe the transformation and write the coordinate notation. Now, when you're working on this on the test, one good thing to do is take a piece of patty paper and put it on the dotted figure, and then see, what do I need to do to get into that other position? And that may help you to see particularly rotations and reflections. So notice here, the first thing I notice I need to do, I'm going to get the dotted in the same orientation as the other one. So that requires me to reflect it across the x-axis. Notice if I go across the x, I get a point that's exactly oriented like the solid figure. Now you see all I need, so that's my first translation. Now all I have to do is translate it 4 to the right. And when I combine these, take the x minus y and add 4 to x, there's my final statement of the combined transformation. In problem 26, start with the dotted one. How do I get it oriented to the same as the solid one? Well, I find I need to rotate it 270 degrees clockwise. You could think of counterclockwise. You could think of that as going 90 degrees clockwise. So in this case, when I do that, notice now I have it oriented the same as 26. So there's my first transformation. XY goes to y minus x. Now notice I need to go up 1 left and up 5. So when I add that to here, there's my final answer, y minus 1, negative x plus 5. Problem 27 asks us to plot and label the image of segment ST after the transformation x plus 2, y minus 5. Now remember, x plus 2 means I'm going to go right, the positive direction, 2. Y minus 5 means I'm going to go down the negative 5. So let's start here. Let's just take t. I go right 2 and down 5, and there's t prime. For s, I go right 2 and down 5, and there's st, and I connect them, and there's my solution. Problem 28 asks us to plot and label the image of st after a reflection over the line x equal 2. So the first thing we need to do is draw in the x equal 2 line. That's a vertical line at x equal 2. Now remember, in a reflection, you go from each point directly perpendicular to the line you're reflecting. However many units it takes you to get there, you go that many the other side. So for example, the first one, t, we go over 2 to the line, so we go over 2 to the other side, and there's t prime. S, we go over 1, 2, 3, 4, 5 to the line, and so we go over 5 to the other side, and there's our point. And now we can draw the line, and we're done with the problem. Problem 29 asks us to rotate this triangle 270 degrees clockwise about the origin, and then graph triangle A prime, B prime, C prime on the coordinate plane. We're also to give the coordinates so we know where we're at. The easiest way to do this is simply to use the rule. XY becomes Y minus X, all right? So let's take each one and do it. So A is minus 5, 1. So we're going to flip them, and the X is going to become negative. So that becomes 1 minus 5 or 1 positive 5. So there's our first spot. And then B minus 3, 3, switch them, becomes 3 minus 3, and then the last one becomes positive, 3, 3. And then finally C minus 1, 1 simply becomes 1, 1. Again, you switched them and became 1 minus 1, and then the X became positive 1. So if we plot those up here, here's A prime at 1, 5. Here's B at 3, 3, and at 1, 1, and there's our triangle there. And that's how we do it. Our last problem asks us to take the triangle. It has the coordinates r 5, 1, minus 5, 1, s minus 3, 4, and t 2 minus 3, reflect it over the x-axis, and then translate it right through. So first, let's put our point. All right, so there's r, minus 5, 1. There's s, minus 3, 4. And there's t, 2 minus 3. So we have this triangle here. So our first thing is reflected over the x-axis. So there's our x-axis. Remember, we're going to just go to the x-axis and then go the same amount the other side. So r is going to go down 1 over 1, and there's r prime. S goes down 4 and over 4, s prime. Now t is going to go up 3 and over 3, and there's t prime. And so there's our reflection. Now we just simply need to translate it 3 to the right. So t goes over 3, r goes over 3, s goes over 3, and there's our final triangle. And if we look at the points there, we have r is negative 2 minus 1, s is 0 minus 4, and t is 5, 3. All right. All right. I hope you do well on the test.